In this example, we're going to build a detergent bottle. I've already imported in a 2D image of the bottle design. This design was created in Creo Sketch and then brought into Creo Parametric and scaled appropriately using the Images command. To begin, I'll create a Freestyle feature. The first step is to choose a primitive as a starting point. Freestyle contains a library of open and closed primitives. In this example, I'm going to be building closed 3D geometry. So we'll start with a sphere. You'll notice a control mesh surrounding the sphere. This consists of faces, edges, and vertices. When selecting any of these elements, a dragger appears, allowing me to manipulate the control mesh and resulting geometry. A selection filter is also available to allow users to individually select faces, edges, or vertices. Drag a box around the left side of the sphere to select the left face. Use the dragger to stretch out the shape to the approximate width of the image. I now need to add more control to the mesh. I do this by extruding or subdividing the mesh. Change the selection filter to face and box select the top face of the sphere. Holding down Alt and dragging will extrude the control mesh to add more elements. Repeat this to position the control mesh close to the hole. Now I need to add more vertical control. Change the selection filter back to All and select the top edge. In the ribbon, expand the Edge Split option and choose 2 splits. This will add 2 columns of elements to the control mesh. The top of the bottle is too wide in comparison to the cap. Box select the top elements, right mouse button and choose Scale. Drag the handle to scale in one direction. Right mouse button and select Transform. Then rotate and translate the control mesh to the approximate location near the cap. This part is symmetrical. Symmetrical geometry can easily be created in Freestyle. Change the selection filter to faces. Orient the model to the top view and drag a box around the top faces of the mesh. In the ribbon, choose Mirror and pick the plane to mirror around. The system will then remove half the control mesh and any changes made to one side will be reflected on the other. We want the bottle to attach smoothly to the cap. To achieve this, we need to create an opening in the geometry. Orient the model to the front view. Box select the top faces of the control mesh. Then either press Delete or right mouse button and choose Delete. Change the selection filter back to All and pick the entire chain of open edges. To select the entire chain, pick one edge, hold Shift and pick the same edge again. This will select the entire loop of edges. Once selected, we can right mouse button and choose Align. Now select the edges at the bottom of the cap. Again, using Shift to select the whole chain. The geometry is now positionally aligned to the cap. Right mouse button on the dashed line and change the connection from positional to tangent. When prompted, pick the highlighted surface to choose which surface to be tangent to. The bottle is now too thin. Select the bottom faces and use the dragger to widen the part. We now need to add the hole for the handle. In Freestyle, we do this by connecting one face to another. Select the middle face where the hole needs to be and choose Mirror Connect from the ribbon. This will connect the selected face with its mirrored counterpart, producing the hole geometry. We want to add an edge at the bottom of the bottle. To do this, we are going to crease the lower edges to produce a hard edge. Later, we will add a round to it. Select the loop of lower edges, right mouse button and select Crease. With the general layout done, we can now select and manipulate the control mesh to get closer to the underlying image. To give the shape more definition, we want to tighten the character lines of the bottle. Select the edges flowing from the hole and apply a crease. This time, change the crease to soft in the ribbon. The area between the character lines needs more shape. If I add a split to provide more control, the geometry will change around the handle area. This is not what I want. Alternatively, I can use multi-level subdivision to keep the shape as it is, but add more control. For each level of subdivision, each face is divided into 4, giving more control vertices. I can now select the necessary points to move. In this case, I will right mouse over the dragger and change the move direction to be normal to surface. This allows me to locally push the surface shape in. I can then return to the base level and finish my design. At any stage, I can perform a reflection analysis to evaluate the quality and flow of the surfaces. Completing the Freestyle feature, I now have a regular cryoparametric quilt. In part 2 of this series, we will build out the individual parts.